Hey guys, this is Linda from your cohort, and I just have heard that some of you, including myself at one point, are struggling with pH, and so I have like a cool little drawing continuum to help remember. So I'm gonna start out with pH. To me is always a spectrum, and I just remember learning that in chemistry, and it's drawing like weird little things, so that's how I remember. And obviously acid is always going to be on the left hand side because it's lower in pH, and basic or alkaline is going to be on, it's acidic and alkaline, is going to be on the right hand side. So when I think of acid, I think, pardon my lemon, but I think of a lemon because they are sour, and acid, sour, you know, that's how it goes. And then when I think of alkaline, I grew up in a place where we had a lot of berries, and if we would pick our berries too soon, they would have a very bitter taste about them. So bitter is an alkaline flavor. So because of that, lemons go on the right because they're acidic, left because they're acidic, berries go on the right because they're alkaline. And then with that, I kind of just continue my spectrum by adding those same colors. So it's going to be yellow, normal is going to be orange because it's nice in between, and then alkaline is going to be red. We're going to go ahead and add our pH values just to help with that. Whoa, it's windy today in California. Okay, so normal value 7.35 to 7.45. That's our happy zone. Anything below that is going to be acidic. Anything greater than that is going to be alkaline. When I think of lemons, let's back up. We're going to put PaCO2 over on this side as well. And it's an increase because when PaCO2 is increased, acidity goes down. Here's how I remember that. Carbon dioxide, when I hold my breath, I start to feel like a tingliness on my tongue, especially in my whole mouth. There's like tingles and kind of prickles and stings. And I find similarities in that to like if I suck on a lemon. Like it just feels weird in your mouth. You got like a stinging sensation. And that is because carbon dioxide, when there's a lot of carbon dioxide in your body, that means that there's also a lot of free hydrogen ions. And free hydrogen ions are what give us our acidity, because it's oxygen being broken down. So because free hydrogen ions are floating around, that means CO2 is also floating around by itself. So in your mouth, when you're holding your breath, you're going to feel those tingly feelings because of the acid from the free hydrogen ions. So lemons and carbon dioxide, sucking on a lemon and holding your breath, are going to have the same feelings in your mouth, of just that tingliness. So then on the other side, if we look at berries, we're going to do bicarb over here. And we're going to elevate it. Because when your pH is elevated, HCO3 elevated, that's when you're going to be alkaline. Whoa! And we're on the alkaline side right now. I lost a pen, but all is well. Okay, so when I think of berries, I think of those like heavily need to be digested. With a lemon, you just suck on it. You're only going to feel it in your mouth. When you hold your breath, it's only in your mouth. And that has to do with breathing. So your lungs. However, with HCO3, that is metabolized, so that you're going to see it more in your kidneys. And I think of like berry juice, all that good stuff that'll go towards your kidneys and be circularized. Cranberries, that's another bitter, I don't even know if they're really a berry, but cranberries, you say drink cranberry juice for your kidneys so that you don't get UTIs, all that stuff. So bicarb goes up when you eat a lot of berries, which are bitter. So we'll pretend that CO3 is a bitter berry, and when you eat too many, you get bitter blood, alkaline, and it's going to be greater than 7.45. I hope that helps a little bit, just with understanding the spectrum of it all. And I thought I would also just go over some problems with you now that we have this in mind. I'll just do it here in the middle just so you can reference the spectrum. Okay, so let's say we have a value of 7.20 as our pH. Actually, I'll do it, yeah. It'll be there for now, but we'll stay, this will be the pH lane, this will be the POCO2 lane, and this will be the HCO3 lane. Okay, so your pH is 7.20. Your PaCO2 is 56. And your HCO3 is 24. How would we know where we fall in the spectrum? Well, 7.20 is definitely going to put us at acidic. And if we remember, acidity means that your PaCO2 is going to be high because it's lemons, yellow, high. We're in this section here. Eat a lot of lemons, get acidic. So, is our acidity high? Well, we remember that our normal ratios for PaCO2 is going to be 35 to 42, and that's actually a measurement of pressure. If you'll remember, it's millimeters per what is it called, mercury. And then the normal for CO2, the normal for bicarb, I'm sorry, it's so windy, HCO3 is going to be 22 to 26. MEQL. So 35 to 42 lemons, let's just say, and 22 to 26 berries. So if you can visualize that in your head, I feel like it might help a lot. Visualize 35 to 42 lemons. Remember, lemons are associated with PaCO2. 22 to 26 berries, and they're associated with HCO3. Okay, so let's go back to our problem. 7.20, we know it's acidic. 56, where does it fall? It's higher. There are more lemons, which makes sense because we're on that side. And then 24, we fall right even. So this means that we are going to have respiratory, because we're talking about lemons, holding your breath, mouth, respiratory, and then acidosis, obviously, because we're on the pH side. So this will be resp, acidosis. Let's do another one. 7.28 pH. PaCO2, let's do 37. And then HCO3, how about 18? All right, so let's see. First, we look at our pH, 7.28. So again, we're going to be acidic. 37 is our PaCO2. We remember that it's 35 to 42 lemons. 37, that would put us at normal. So even though we're acidic, we know it's not going to be respiratory acidosis because that's looking normal today. Let's look at our bicarb. 18. 22 to 26. So 18, as far as bicarb goes, is going to shift us on down to acidosis again. Because if it's higher, it's going to be more alkaline. If it's lower bicarb, it's going to be on this side of the spectrum. So we are, again, looking at acidosis, but it's metabolic. Because of that bicarb, because of those berries you're eating that are going and reaching your kidneys. All right, let's do another one. 7.56. 20. 25. 7.56, sorry, we're doing pH on this side. We have our little lanes, I just did it wrong. Okay, 7.56, we're looking a little alkaline today. 20 is our PaCO2, that has to do with respiratory. Lemons in your mouth, holding your breath. 20 falls pretty low. So that means we're going to be further this way on the spectrum because higher is going to be over here. So 20 is pretty low. We'll fall over here somewhere. How about our alkalinity with HCO3? It's 25. That's normal. So we're obviously not alkaline. Or, I'm sorry, we are alkaline, but it's not going to be metabolic because our metabolic is normal. This guy's normal. So it's going to be respiratory alkalinity or alkalosis. Okay, We'll do one more. I'm sure you can guess what it is. 7.71, 36, 31. Okay, so 7.71, again, we're following more on the alkaline side. 36 is our PaCO2, and that is normal, so we're good. Don't even worry about that right now. And then 31, oh, and again, because it's normal, we're gonna rule out respiratory. 31 is our HCO3, and that is abnormally high. So we fall all the way on this side of the spectrum because we have an alkaline pH and an alkaline HCO3, or a high HCO3. So this is metabolic alkalinity or alkalosis. I hope that helps some.